Alright, welcome back class. So again, this is the last part. We're finally going to finish section 5.2. I know it's extremely long. I got into graphing, but today we're actually going to see one with, how do we actually graph the ones with the major humps? Okay, how do you know which direction to go in? Okay, so again, we're going to tie it into end behavior plus plugging in points. Okay, alright, let's go ahead and get started. And again, I want you to try for homework once I'm done with this lesson. I want you to do 2 and 3 for homework. Okay? And again, if you have questions, those are the questions I want you to ask in class tomorrow. All right. All right. So going back to yesterday's video, okay? I told you the easiest way to graph is using the t-table. So again, I'm going to use the same points. I'm going to use 0, 1, 2, -1, and -2. Alright, so again, these are the x's that I came up. You could come up with any x values, but again, we want to use the easy x values unless you want to make your life harder. Choose bigger numbers. Okay. All right, plug in zeros. That means I have to plug in 0 into the function. So f of 0 gives me 0 cubed plus 2 times 0 plus 3. Anything to the 0 power is still 0. 2 times 0 is 0, so we get 0 plus 0 plus 3 still gives me 3. And again, I want to show the work for the first one so you understand where these numbers are coming from. Okay. Common mistake for students is when they plug in the negatives. Okay. Remember, I'm going to do one for you guys. Make sure to write the parentheses because you're plugging in -1. Okay. All right. So -1 cubed is -1. 2 times -1 is -2 plus 3. All right, order of operations tells us to do negative, adding or subtracting from left to right. So this is the left, so -1 minus 2 is -3, plus 3 is equal to 0. Okay. All right, for these 3, I'm just gonna verbally say, you guys can practice this at home. If you plug in 1 cubed, 2 times 1, plus 3, you get 1 plus 2 plus 3 gives me 6. Okay? Alright, I'm going to stop right here. Because if you notice something, it starts off with 0, then it goes up to 3, then it goes up to 6. So, if you wanted to know what this number is, like take a guess, okay? Or make a conjecture, I think the graph is going to shoot up to infinity, okay? But again, we're tying this into end behavior. So, if you think about it, we could use end behavior. Because if we know that this is going to go up, we no longer have to plug in 2. How about let's plug in more negative numbers? So that's how you know, okay, where to keep going. So that's what I mean. You don't always have to plug in these points, okay? Look at the answers you get. And again, if that doesn't make sense, again, when I show you on the graph, hopefully it makes sense. So I'm going to stop right here. Okay. I'm going to talk about end behavior next. All right, so again, talking about end behavior, okay, we have degree. The highest degree is 3, and that's an odd number. Okay, leading coefficient is 1. So leading coefficient, or LC, is equal to 1, which is positive. Okay. All right. So I'm going to give you an estimate of what the graph is doing with an odd and a positive. And odd and positive, okay, function, okay, the degree is odd, the leading coefficient is positive, the graph should do something like this. Okay? What happens in between? That's what we're going to use the n minus 1 terms. Okay? So, my conjecture was right, my hypothesis. I believed, if we come back over here, that if I plug in 2, that number is going to be positive. And now I know it's true, because the end behavior is shooting up to positive infinity. So, instead of actually plugging in 2, I'm actually going to go ahead and plug in negative 3. Okay? But let's go ahead and plug in negative 2 first. F of negative 2 gives me negative 2 cubed. Negative 2 cubed is negative 8. 2 times negative 2 is negative 4. Order of operations tells me to subtract that negative 8 from 4, gives me negative 12, plus 3 gives me negative 9. Excuse me. And again, to me, negative 9 is a big number. Okay, I'm going to go ahead and switch it to my graph. My graph goes only up to 5, 6, 7, 8, 9, 10. Okay, so if I plug in negative 3, again, let's look over here to our end behavior. End behavior is telling me that the graph is going to shoot down to negative infinity. So I actually have enough points to graph. Okay, so you can use those 4 points in order to graph the graph. Okay, if that makes any sense, graph the graph. All right, how many turns is the graph going to have? Okay, if you forgot, the formula is n minus 1 turns. Okay, again, where do I get n from? The highest degree, which in our case is 3. 3 minus 1 is equal to 2 turns. Okay, they call it turns, I call it humps. All right, so let's go ahead and finish this. So positive 1 is 6. Zero is 3. Negative 1 is 0. And negative 2 is negative 9, which is down here. 5, 6, 7, 8, 9. Okay. So I think that the middle is going to be right here. Okay. I could actually plug in 2, and I know that the number is going to be big. Why? Because of the end behavior. So my graph looks something like this. I know at first it's going to be hard. At first it's going to be hard to graph these. Okay. But the more you do it, the more practice you're going to get. So it's shooting to negative infinity, going up, and it changes direction here. And graph that again. Okay, so that's what my graph looks like. Again, you can't really see the turn, but if you think about it, this right here, you're going from negative infinity to 0, and then it shoots up to positive infinity. Okay. So again, on the quiz or the test, if you make a straight line, try not to make a straight line because you know it has a hump or it has a turn. And I proved it, it's right here, 2 turns. So here's my first turn right here, and here's the second turn. Again, it's so subtle that it's hard to see, okay? But if you graph this one on decimals, zoom in and you'll see where the turns are at, okay? All right, so the trick is, again, actually pay attention to the values that you're getting, okay? You didn't want to plug in 2 because the answer was going to be positive, okay? And how did I know that? Because I tied it into end behavior. So that's where end behavior and the graph comes hand in hand, okay? All right, so again, go ahead and try numbers 2 and 3. And again, if you need help, double check on, I'm not there with you guys, but you have decimals. Graph those on decimals.com, but first graph it by yourself, okay? And if you have any specific questions, ask me tomorrow in class, okay? All right, so up next will be, the next video I upload will be about 5.3, okay? Factoring polynomials. All right, see you guys.